Hello. So it's already chapter 10. So in chapter 10, we are going to do the second part of hypothesis testing. In the previous chapter, we learned the basic framework of the hypothesis testing. We learned like p-value, t-statistic, critical values, when to reject, how to calculate those statistics and p-values. So today, but what was missing? Like some important things, some important discussions was not uh, done in the previous chapter. They are these two. So first, whenever you develop a statistical inference method, always you have to think about its error. So as a statistician, as a statistics practitioner, you have to admit that, always acknowledge that the possibility of error, right? That's statistics. Like there must be random errors. So whatever you do, there will be some probability that you are wrong. So then, however, we overcome that error by calculating the error. So if we know that the error exists, but also we would like to minimize the probability of that error. So that's what's missing from the previous chapter. I only gave you how to implement the hypothesis testing, but I did not say how good this is and what is possible errors and what's the chance of error. So we are going to do that. We are going to discuss the accuracy of a hypothesis testing, what kind of errors can happen and how likely they are. And second, in the previous chapter, I said you have a statement, then you can test it. But actually, the hypothesis can take different forms. Like it can be defined with an inequality or in different forms. But earlier, I only considered mean equals to certain things. But in most cases, hypotheses are more likely formulated with an inequality. Like for example, I believe like the gas price is greater than $4, for example. Then it's an inequality. So it's not a big difference, but so we need to modify the hypothesis testing we learned in the previous chapter to accommodate inequalities. But idea is still the same. So let me start with the first topic now. So we'll go back to the example of legal criminal trial case, like a presumption of innocence. So consider you are in a criminal trial. So like you are a jury or the judge, whatever. In that case, the null hypothesis is that the defendant is innocent. So if there is no evidence at all, then you have to conclude that the defendant is innocent. The presumption of innocence. And the alternative hypothesis is that the defendant is guilty, right? So in this case, your decision is either one of these two. The null hypothesis rejected or not. Or you can say not rejected as accepted, but as I explained in the previous chapter, I prefer non-rejection than acceptance. So if you reject the null hypothesis, that means you are sending the defendant to jail. You conclude the defendant is guilty, so he will go to jail. But if you do not reject the null hypothesis, and if you find the evidence is not strong enough to conclude that the defendant is guilty, then the defendant will be set free, of course. So there are two possible results depending on your decision. But actually, that's your decision, but actual truth could be also different from your decision. Of course, you don't know. No one knows what's the truth. But just let's imagine there are two possible truths. One is that the defendant could be actually innocent or could be actually guilty. So no one knows. But depending on what was the truth, your decision could be wrong or could be right. So that's the error, right? That's the error. Of course, the error happens because the truth is unknown. So we will assume what is the truth and then think about the probability of error. So then the contingent tree. So suppose that the truth is innocence. So actually, the defendant was innocent. In that case, if you reject the null hypothesis so that the defendant is sent to jail, then you made an error. That is a mistake. That's an error, right? If this is the truth, jail, like rejection is an error. But of course, the other side, if you set the defendant free, then that's correct, right? On the other hand, if the truth was guilty, then you have to send the defendant to jail. That would be the correct decision. That means you have to reject the null hypothesis. Otherwise, if you do not reject the null hypothesis, then it is another error, right? So, as you can see, there are two different types of errors. Sometimes rejection is an error, and other times non-rejection is an error. So, of course, that depends on what is the truth. But of course, the truth is unknown. So we need to imagine what is the So we have to think about three different things. First, the truth. That's the truth. And then we have to think about the hypothesis. Hypothesis is just hypothesis, which could be different from the truth. And third, your decision. Your decision or the data, the observation, your decision could be rejection of the hypothesis or not, and also could be different from the truth or not. So there are three different dimensions we have to think about. In each case, there are two different scenarios, like in the hypothesis, in your decision, in the truth. So 2x2x2 case, right? It's in the simplest setup. So then, in general, so the example was about criminal trial, but you can put translate that into the general statistical terms. So in general, what we can say is, if suppose that the null hypothesis is true, if it was true, then rejection would be an error, and we call this type 1 error or alpha error. I don't like the name. The name is not that intuitive. Like type 1 and type 2. So even I'm confused sometimes what's type 1 and what's type 2. But yeah, this is the typical term, common terminology, type 1 error. But if the truth was that the null hypothesis was wrong, then you had to reject. But if you do not reject, that is another error, which we call type 2 error or beta error. Usually I am going to use type 1 and type 2 errors in this course, but some textbooks, old textbooks, could call this alpha or beta errors, right? So clear, it should be easy to understand. Now we are going to use the normal distribution idea again. So suppose that think about the examples we considered in the previous chapter. For example, I believe that students study 40 hours before the final exam. For example, that's my belief. Null hypothesis. Average study hours for the final is, say, 40 hours. That's I believe the true mean is here. But that means I believe it here. And if the data realized somewhere outside, away from my belief, then my belief becomes more like questionable, more suspicious. Something is going on. Something is not right? Something is not like they are not consistent. So we know, like this is exactly the idea. If the observations are further away from your belief, something is not right. So as a result, we will decide to reject the null hypothesis if the sample mean is like outside, like here. For example, like so we determine if the observations are the distance from the belief, distance between the belief and the observation is too far, then we are going to reject. And we determine that area as the rejection region. We call that rejection region. And if the observation lies here, we are going to reject. And then we call that cutoff, the thresholds, as critical values, right? So critical value, lower critical value, upper critical value. So that gives you an interval around your belief, so that your belief is not rejected within that area, right? Then, so this is what we learned last time. So that area, the rejection region and the critical values are calculated based on this distribution. We assume normal distribution using the central limit theorem. That's not a problem. Normal distribution is not a problem, but the problem is we assumed that the null hypothesis is true. Your hypothesis is true. So because we assumed my hypothesis is true, so the normal distribution is centered around here. But if that hypothesis was wrong, normal distribution would be centered at a different point, right? So, for example, so if this was correct, if your hypothesis was correct, then we could imagine normal distribution like this, and we could calculate the probability of the rejection region. So if your hypothesis was true, then still the observation could realize according to this distribution. Then if by chance, if the observation realizes in the rejection region, then you have to reject the null hypothesis. So this area is the probability that your observation falls on the rejection region. So rejection lower side and upper side. Rejection so this probability will give you type 1 error, right? Again, listen carefully. Type 1 error is when you reject the null hypothesis even if it is true. So null hypothesis is true, that's the condition. Null hypothesis is true, so the normal distribution is centered here, and your observation will be distributed like this normal distribution. Still, it could be still your observation could be different from your belief just because of random error. That probability, and if the random error is too big, then you have to reject it. That probability is the type 1 error probability, right? This is how we calculate the type 1 error. Now, then, on the other side, now we are going to assume that the null hypothesis is wrong. If it was wrong, then, as I said, now the center of the normal distribution is not at your hypothesis. There must be another value, a different value, where your null hypothesis, your distribution is centered around. So your distribution is centered at another point. I'll call that mu1, right, which is different from your belief mu0. Then now, your data, your observation will be distributed this way, right? A little bit shifted this much. As like the more the null hypothesis is wrong, the normal distribution would be like more different from the distribution you assumed. So in this case, now we assumed the null hypothesis is wrong. So null hypothesis is wrong. That's the truth. So the data will be generated according to this distribution. In this case, you have to reject the null. That's the correct decision. But this much probability, with this much probability, your data will be generated within the critical values so that you cannot reject the null hypothesis. In this case, just by chance, your data looks like it is close enough to the null hypothesis. So you could not tell the difference. So that is type 2 error. Again, type 2 error happens when you fail to reject a wrong null hypothesis. And so, like, even if the data is generated from a wrong normal distribution, but still there is probability near the null hypothesis. That's type 2 error probability. Right? This is the basic overview of the idea of how we calculate the probability of errors, type 1 error and type 2 errors. We are going to use some numerical example, to actually calculate the probability. So it will be maybe most difficult algebra you are going to see in this class. Okay, I'm going to do that with an example in the next video. See you there. Bye.